Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at circuit descriptions in Revit. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So for circuit descriptions in Design Master, the most important thing to know is that Design Master takes over control of circuit descriptions from Revit. Previously, before using Design Master in Revit, you would set the circuit descriptions in your panel schedules. So if I pull up the panel schedule here, you have your schedule, you have the circuit descriptions, and you would type in the descriptions here and manipulate the circuit descriptions in your panel schedule view. With Design Master, you no longer want to do that. Instead, you want Design Master, Design Master is going to control them, so you want to make sure you're working with Design Master in the way it's controlling your circuit descriptions rather than fighting against it. Because if you're fighting against it, you'll make changes here, our software will override it, and then you'll be very frustrated. But if you work with it, it actually, we like to think, is a better workflow than what Revit provides. So if I go, I'm actually going to go back to my family here. There's multiple layers of places you can set your circuit description. So I'm going to kind of start at one end and work toward the other places where you can set it. So I'm going to take this family, and I'm going to run the Revit edit family command. And then in Design Master, we have the family edit command. I'll run that. And this is where you can set information specific to this family. In this case, we want to set the circuit description. So this is what will be filled in when you take a device of this family type and connect it to a circuit. So I'm going to type in cooling tower there. Click OK. And I'll load that into my project. Overwrite the values there. And now if we take a look at the circuit that this is on in the Design Master circuit edit, you can see that the description for this circuit is set to cooling tower. Now that's being pulled from that family definition that we just did. So you can have for each family type an overriding description. So if you had a receptacle, you could say receptacle, and then all your receptacles, when you connect them to a circuit, are going to say receptacle. You can also then, at the instance level, set the description for that circuit. So if I go to the instance edit, you can see we're pulling in the circuit description from the family. We can also choose to override it and provide something specific at this instance. Maybe this is cooling tower number 1. So we want to differentiate this between the other cooling towers in the project, so we give it that description. Click OK and pull up the circuit again. And now you can see that the description at the circuit is pulling the value from that instance. So we have the family level, and then we can override it at the instance level. You also, in the circuit edit command itself, override these values. So we can add a prefix if you want to add additional information at the beginning of your description. We also have a suffix that goes at the end, and then we have the replacement. So for the prefix, we could put existing if it was an existing cooling tower or something of that nature. Or we could here in the suffix on the roof, something like that. So you can add additional information if you want to do it. And this is specific to that circuit. So if we move to this cooling tower somewhere else, this circuit would still have that information attached to it. Finally, you can use the replacement to completely replace the circuit description. So if you have something very long, if you've got a bunch of different pieces of equipment and the description ends up being longer than you want it to, you can just type in a replacement here. And whatever you type will completely overwrite what is in there. So the idea is to give you better control of your descriptions. Typically, you're setting it rather than in the circuit itself. You set these circuit descriptions in the family or in the instance, and it fills in the circuits. And then when necessary, you can update the circuits with these additional settings. We also have the option to include the room name in the description. So if your devices are actually in a room, it will be included in that circuit description. You can also specify whether that's on or off by default by going to the options. And you have for your circuit descriptions, include room names in circuit descriptions, yes or no. So you can turn that on or off at a global level, and then for each circuit, you can turn it on and off as well. That's for descriptions of what we consider branch circuit devices, receptacles, equipment connections, light fixtures, things like that. We also have what we consider distribution equipment, panels and transformers, things of that nature, and they're handled a little bit differently. So if we go take a look at a panel, I'll pull up my view that has a panel here, and we will go take this MDP1, and if we run the panel edit command, we have the description and upstream panel. So wherever this panel is connected, it will use this description. By default, it just matches the name of the device. So it's just going to pull the device name and fill that in the upstream panel for you. You can override that. So if you want to say panel MDP1, we could do that. And then in the upstream circuit, it'll actually specify that. So if we go to the switchboard, take a look at the circuiting, you'll see that it's pulling that panel description now. We also have the ability to set some defaults in the family again. So if we exit out of this, run the family edit family command, and then the Design Master family edit. We need to change our device type to a piece of distribution equipment so that it knows that Design Master thinks that this is a piece of distribution equipment. Other panel and transformer all have the same setting that we're looking at here, which is just the upstream description, prefix, and suffix. And this is where you can add a specific value that's going to be added to the beginning or ending of that description. So if you always want to say panel and whatever the name of it is, you could put a prefix in there. And then you could add additional information. Say this was actually a panel, and you want to say that it's a main lugs only panel, but you want to call that out in the circuit description. You could do that so that we always know, and then I'll always get included. So if we click OK, load that into the project. We still have that custom description. We'll change it back to default. And if we update it, you'll see that it's pulling in that prefix and the suffix from the circuit description set in the family. So now any family instance using that type is going to have that description as the default value. And then again, we go up to the circuit, and you'll see that it's being filled in there with that information. And so that is how you handle circuit descriptions in Design Master and Revit. Again, the most important thing is that you don't want to go and change what you're doing in the panels themselves. Just as an example of that, say we come in here and we type in something different. When you go to our software and run the calculate to update all your values, we're going to go through and fix your circuit descriptions for you and make them what they should be. And so that's where we go and we change that something different back to the CT1. So if you do want to change it to a different value, don't do it through the Revit panel schedule interface. Do it through our circuit edit command. And the reason that we don't allow you to make changes is because that single field where you can type stuff in isn't sufficient for all the different things you could want to do. So if all we had was basically the description replacement, we could do that. But it doesn't have a place to say, well, I want to add a little bit of a prefix, or I want to add a suffix, or maybe I want to control whether the room name is in here. So we have all these additional options that are varying shades and degrees that you can modify that description, that simply modifying just the description itself doesn't give sufficient information for what you were actually trying to do. So our circuit details gives a more complete and thorough ability to modify that description. Any questions on circuit descriptions and how those work in Revit? So Scott's question is he would like to know if there's a way to automatically not show the ground from a utility transformer to the service entrance without basically manually specifying it in the panel edit command. So in the family itself, you can specify the ground size. The default is obviously size automatically. You can choose to size it based upon 250, 122, or 102. You can also set it to be none. So if you have a family set of utility transformers that you're always using for that purpose, you could set it here, set it to none, and then use those transformers as your utility transformers, and then they will have no ground included in their feeder size. So that would be the way that we have to do it. It is handled at a family level. We don't have any way to differentiate. Just know that, okay, this is the utility one because it's connected to the service. So that's how you can do it. Not sure if that handles what you're looking for, but that's the option that we have. And that will be the feeder to the transformer. Scott's clarifying that he's looking for no ground between the transformer and then that first switchboard. So yeah, if you wanted that, you would need to go to the switchboard family and basically create a switchboard service family that you use for those service entrances and make the setting there. Because setting it, the transformer isn't right. You need to set it here. So I set that to not have a ground, load that back into my project, overwrite. And then when we do the panel edit for that switchboard, the ground is set to the family default of none. And then you can obviously always override any of our settings at the specific level, but that would be the way to get that to have none. Going back to Tyler's question, he is having trouble getting anything to export from Revit to AutoCAD. So I will walk through the process of exporting from Revit to AutoCAD to show you how it should work, and see if a step was being missed there. And it's possible that there are other issues going on as well, specific to the project. But in general, it should be a fairly straightforward process. In Revit, run the panel edit command and confirm that this tree here looks like it should, that you've got the pieces of equipment in there and that they look like they're connected as you're intending them to be connected. Because this is basically what is going to be exported. So run the panel edit, make sure that looks good. Then in AutoCAD, you do need to start your project. I'm going to start up AutoCAD here, and we'll wait for a moment for it to load. So you can't just export. You need to have a place to export to. It's basically creating a drawing and running the start project command. I'm going to save this drawing to a location. So I create my file. I save it to a location. I go to my DM Electrical RT ribbon and run the Start New Project command. Well, you've got options here. None of them really matter. We'll click OK. That creates the project to export to. Then in Revit, you run the export one-line command. I'm going to choose a new location just so that I'm exporting to that new spot. Training folder there, you select the .dm file, which is our database file that you're going to export to. And it does its work. It's going to spin for a little bit. If you look at that folder before you do anything, you will see that it does create this text file, we basically write all the information out to a text file and then read it in. It's kind of a little temporary file. You don't otherwise ever need to do anything with it, but that's just kind of in the background what's happening. So it writes that file. Then in AutoCAD, we basically click any of our RT commands. It'll look for that file, see it, and pull it in. So I'll click the generate command. It'll see that there's that file. It'll start importing it. It's going to prompt for some feeder IDs. I'm going to tell it to just create the feeder IDs automatically. It'll get all our connections. And it pulls everything in, and then you can see here we've got that same list of equipment and that same tree. Now we can actually generate the one line. So that's the process that it should happen. That's the way it's supposed to work. Certainly, there are possibilities for things, if you don't have them configured right, to run into problems in that workflow. But that's the basic workflow. That's how easy it should be. If it's not that easy and you're not seeing it, then something's going wrong and we should figure that out. But it should be that easy. And then you run the generate and you got your nice looking one line here. So having seen that, Tyler, where in that process were you getting stuck? So Tyler's saying it was making it all the way to the text file, then nothing in CAD. Tyler, do you also use our AutoCAD-based software, our Design Master Electrical? Ah, okay. That explains partly what might be going on. So for people who use both our Revit software and our BIM package that runs in AutoCAD, there is an additional step that you'll want to run. So on the DM Electrical ribbon, if you just started running commands, it wouldn't pull that text file in automatically because it kind of thinks it's just a regular Design Master file. So you need to click on this one-line diagram, and there's this import from Revit. Run that command once, which basically triggers it and says, okay, this is actually a Revit project and not a standard Design Master project. And then it sucks that information in once and will in the future know to look for it. And since we're here, I'll highlight the other little RT command. We have this edit distribution equipment command. So when you're working in Revit and you have our RT ribbon up and you run the edit command, you get kind of this stripped down dialog relative to our others that just has some block settings for the one-line diagram. If you don't have this ribbon and you have our full electrical ribbon and you run the standard device query, it actually pulls this up like it's a Design Master panel. The problem is that any changes you make here are not going to feed back into Revit. So you don't want to use our standard Design Master commands. Instead, if you run this command here, the edit, it'll give you the Revit version of that command with only the settings that you can change that are actually going to have an impact on that project. Could I run through a quick example of editing the blocks used in the one line? I would be glad to do that. So we have in our software, obviously, our default customization. It has a look and feel to it. It's not going to match what your one-line diagram looks like, and it's not going to have everything that you want to use in it either. So we have a lot of ability to do customization, and it's not terribly difficult. You just do need to know where the commands are and what buttons you want to press. So for this example, we will make a new block. All right, so Scott wants to see a smaller standard panel. So we have two types of blocks. We have the blocks, and then we have the panels with the bus bar entity. So block is something like this transformer where the graphic is fixed. It's a block in AutoCAD. And then these panels are actually different. If you click on them, you get a lot more grips. You can move this bus bar around. You can actually resize them. So the panels are a slightly different entity. They're not just a block. You can actually modify them and adjust them. That's how we get things like these switchboards or these horizontal bus items where they're different sizes because as you change this, actually the whole thing resizes. So it's really nice for laying out your panels that are going to be different sizes. So what we can do to make it smaller is we can take this panel here and any changes we make are what's going to be stored. So I'm going to remove the bus bar or the bus. just to clean the whole thing up, I'm going to move it out here just so we have a little more space to work. I'm going to make the whole thing smaller, something like that. And then we can also modify the labels that are going to be shown. So any labels that we add or subtract here are going to be saved and used for the future. So if I run the insert and modify command, I can select this. Currently, I'm just showing that one label. I'll call this panel. So add a suffix there. And then say we want to include the bus amps as well. Click OK. And we'll group that with this one. And because it's small, maybe we move it down here. And as a final step, I'm going to center that whole thing. So make the panel look how you want it to look in your project. So however it should look, get that right. Then you go to the Customization tab, and we want to create a block from one-line diagram. So basically, this is a one-line diagram. It's got some labels already, and we want to save that for future use. You run that command, it's going to prompt you for some information. I will call this small panel because it's a little bit smaller. We have the option for the type of block. This is distribution equipment. And then we can create a record in the project database or the master database to use. I'm going to put it in just this project, call it small panel. And then it'll prompt for the device to include, select it. You can also include additional graphics, and I'm actually going to demonstrate that just so you know how that works. Say we have a little ground that's being shown. And this is not terribly well drawn, but you get the idea. So say you want to include that little ground piece and have it included. This will insert that piece as part of the block every time it's used. So I'll add that just as a little additional piece. Create the block. It's going to prompt for the piece of equipment, the additional graphics. So I'm going to grab this ground. It kind of flashes at you and does its thing. And so now it's created that block. And now we can, just as a first step, I'll just insert it. I'm going to get rid of this panel so I can insert it. So we've got our list of blocks over here on the right. Scrolling down, we have the small panel choice. It created this little graphic so we know what it looks like. Click OK, and we can put it on the drawing. So it comes in with that size. It has the label and size down here. And it has this additional graphic. At this point, these are standard AutoCAD entities. If you need to make changes, it's kind of your responsibility to modify them. So if we come in here and we resize this, it doesn't know to do anything with these. So just be aware you have to modify those and maybe move them if you want to do that. So that would be how you create a standard smaller panel. You can set the default panel that's going to be used. So there's a couple other options to look at that are of interest here. So for the one line that we're doing, we have a default for each block. So it's using just a custom box with bus. So it's kind of drawing in a custom box panel for each one. So if we wanted to override it, we say, okay, I want to use the small panel for all of those. We could change that here and say, okay, let's use the small panel. So now our default panel is going to use that new block that we created. Once they're in, we don't check it anymore, and we're not going to make any changes. So if you actually are making wholesale changes, you erase and regenerate. You don't generally want to do that in a project, but as you're working on your customization, that's the easiest way to get things updated. And so now they all come in with that panel. So it's looking a little bit closer, assuming this is what you want it to look like. It's coming in looking how you want it to with those graphics being included. The other option that you do have, if you keep this as the custom panel box with bus, we also have the default panel box height and width. If you just want to have it go in just as a box without any fancy labels or anything, you can just change the size here as well. So we could change this. I'll just make it bigger so it's obvious. I'll make it a 2x2 square. So if we change this height and width, and now when we run the generate, it'll generate with those sizes instead. So that's what it would look like coming in as a 2x2. So if you want to change that default size coming in, that's another place you can do it. And finally, if I take MP2B and reinsert it, when you have your block, if you are doing a custom panel box, you can either draw in the size, or you can check this box and draw it in at a specific dimension if you're inserting one at a time, adding additional panels kind of at the end of a project. So if this is unchecked, it prompts you for the actual size of that panel. If you want to have it come in at a specific size, you can check this box and then it'll prompt you for that size and put it in for you. Additional question, I have all my options set in Revit. I know I can export them, but how do I set them for a template? So in Revit, we have the customization, and we've got all these choices here, the options and all your wire sizing. And so the question is, how do you use those in future projects? And there are two choices for handling that. One is that you can export them to an external file, and then in new projects, import it as a separate step. So you can export it, save that file somewhere nice, and then just run the import. You can also open up your template file itself and run these same commands in a Revit template, and it'll save those values so that when you start a project from that template, it has all those values set in it automatically. That actually eliminates the import step. So you start from a template and you've got all your values. So if you ran an export, you could go to your template, import them. The template would then have all the customization set. And when you start from that template, you're good to go. That was actually our original idea, is that we would just set them just in the template. We didn't originally have the export and import command, but we found that people are varied in their workflows such that setting it in the template was not working for some people. They needed the export import. So we added those as a solution for people who are not working as reliably from templates. But if you do have a template, that is kind of how we thought it seemed like the more traditional standard best practice Revit workflow. So put everything in the template and then you're good to go. So Revit by default has a fed from parameter where it shows you where the main panel, the device is fed from, which is helpful. But if you have something like a transfer switch, it's fed from two locations, and Revit doesn't have any way that it shows where that second connection is coming from. So in Design Master, we added an additional shared parameter, the design DMET panel fed from to, where if you have a transfer switch, we'll fill in where the second source is coming from. For completeness, we also added this fed from that'll show you the first source. It's a duplicate of what Revit shows you, but we put it in there anyway. So we have those two Design Master ones, and the fed from to is the more important of those because it shows you where the transfer switch, that second feeder, is coming from. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.